So one of the applications that we're going to look at in this session is compounded interest. There's two formula for this compounded interest, and you need to remember those because on the test, the formula will not be given to you. Okay, the first one that you see is compounded a certain numbers of times. The interest is compounded a certain numbers of times in a year. Okay, so that's the first formula right here that we are talking about. So P represent the amount that invested, okay, the principal. R is representing the interest rate, and T representing the numbers of year that is being invested. And N is basically how many times the interest is compounded in a year. So if you are, this N can be compounded twice a year, semi-annually, quarterly, 4 times a year, monthly, 12 times a year, weekly, 52 weeks, and daily, 365 days, so on and so forth. Right? So those are the cases that we can have. So another compounded interest is compounded continuously. So every fraction of seconds you are getting interest. So that kind of situations we use the formula A is equal to P times e to the RT. So that's where we use natural exponential. So in here we're gonna try to look at examples which ask us to compute at different cases, and you really need to have your calculator ready because otherwise you won't be able to compute it by hands very quickly, and especially it's very difficult to compute it just by hand. So calculator is a must-have for these type of problem. So what we do is first collect the information. Right? So in example 6, Angela invested 15,000 in a saving account, and then the interest rate is 4%. How much will be in the account in 10 years by each method of compounding? So in here, what we know is we know the principal is 15,000, and we know the interest rate R, and we know how long we're going to be investing in 10 years. So those are the first thing that we want to collect and then write it down. So I know that in this case my P is 15,000, and then the interest rates change it into decimal number, that will become 0.04%. And then we know that the time, the T is what? 10 years. Now, to answer the part A questions, it is compounded quarterly. Right? Compounded quarterly. So that means for part A, my N will be equal to 4 because quarterly. And this allows me to use all the information to find out what is my amount after 10 years if you compound it quarterly. So according to the formula, this is what I'm going to plug it in. My amount, the final amount, will be equal to the principal, 15,000, times with 1 plus the interest rate, 0.04, divided by the numbers of time is compounded, n, 4, and then to the n times t to the power of it. And since we are talking about dollar amount, we can approximate it to 2 decimal places to the nearest cents. So make sure you plug it, type it into your calculator very carefully using appropriate parentheses and everything. Right? So 1 plus 0.04 divided by 4, and then to the power of 40. So this gives me the amount of 2233, 2.96 after we round it up. So try to use your calculator and see you got the same answer or not. Okay. And second is compounded monthly. So when we talk about compounded monthly, that will be B, N will be 12 months. So similarly, I'm going to put it into the formula. Here's my amount, 15,000. 1 plus the interest rate doesn't change. But since it's compounded monthly, my N will become 12. So 12 times 10. So now use your calculator and then see you got the same answer or not. So this gives me 2236 2.49. That's what I got. And lastly, we're going to try to find out the compounded interest for continuously. Okay? Compounding continuously. So that means we're going to have to change the formula. This time my formula will become A is equal to the principal, which is 15,000, times with e to the RT power. So my R will be 0.04 times with t 10 years. So in your calculator, you should have this function key e, right? So 15,000 times with e to the 0.04 times 10. And that gives me my answer, approximately 2237, 7.37. So notice that the values are very, the final amounts are very close, right? So the formula is a must that we need to remember and then plug it into the formula correctly. Right? So let's take a look at on the next example. So in this example, it said that Hector invested 10,000. So we know the principal. At age 21, he hopes that investment will be grown to 150,000. So the growth will be 150,000. So that's our final amount that we want. Right? If the interest is compounded continuously, so it's telling you that the interest will be compounded continuously, and approximately what rate of growth will he needs to achieve his goal. So that means it's asking you what rate of growth. That means what is the interest rate that they want. So in this case, I know that my principal is equal to 10,000, and my amount, the final amount that we want, is 150,000. Right? And then from here, I know the times, because the time is what he started at 21 and it ended up in 50. So 21, 50 take away 21 years, right? That will give me what, 29 years that he needs to invest it. So the amount of year is 29 years, because starting from 21 and then done. So, and what we don't know is what is the interest rate that they require. So that's the problem. So compounded continuous interest, so P is, we know that the formula is this, A equal to P times e to the RT. So this is more of like solving equation case now. So A, we know that our final amount must be 150,000, and then we put it in 10,000, and e to the R, which is that's what we're looking for, times with 29. So we are looking for, or we are solving for R, which is solving for exponential equation. So to solve for exponential equation, first we check, can we rewrite it into the same base or not? In this case, there's no way I will be able to write it into base e. So therefore, I need to use ln. But before I use ln, then I need to divide both sides by 10,000. So that gives me 15 is equal to e to the 29r. Now, solving this exponential equations, we're going to have to use ln to bring down that exponent. So take ln on both sides. It'll be 15 is equal to ln of e to the 29r. So by using the properties of logarithms, I can bring this 29r to a base level. So 29r times ln of e. So we know that ln of e is basically equal to 1, so that will be ln of 15 is equal to 29r times 1, which is 29r is equal to ln of 15. So therefore, to get my r, I divide both sides by 29. Now, we're going to have to use approximations because whenever we talk about interest rate, it is what? All the way up to like 3.45 or something like that, right? 2 decimal places. So it will be ln of 15 divided by 29, which gives me my answer is approximately 0.09338, so on and so forth. So we count up to 4 decimal places right here, right? So that will become 0.0933 approximately. And then if I multiply by 100, that will become 9.33%. So approximately you need 9.33% to achieve this goal. So this type of problem is very, you're gonna have to use that in somehow in your life also, right? For your retirement plans and stuff. So the next topic that we're gonna talk about in the next video is exponential growth in decades.